guys, this is independent lesson 2.3, correlation. So the definition of correlation given right here, this is just something that we are going to measure or use to measure the strength and direction of a linear relationship between two variables. Yesterday, we talked about how we can sort of just guesstimate what the strength is of relationship, and now we actually have a number we're going to use. So a couple facts about correlation. If we have a perfect linear positive relationship, that correlation, we define it with the letter R, is going to equal +1. And if it's a perfect negative linear relationship, that correlation R is going to have a value of -1. So if correlation makes no distinction between the explanatory and the response variable, that means that if we were to, let's say, flip the variable that's on the x-axis, so that explanatory variable, to the y-axis, and the same thing with the y-axis variable to the x-axis, so taking that response variable and moving it to the x-axis, that correlation R would remain the same. Also, correlation R does not change units of measure. And this is because that correlation R, that is calculated by standardizing the two variables. So kind of like a z-score. So it is calculated by standardizing the two variables, x and y. And when we talk about standardized values like z-scores, they don't have units. So we just say the number as is. The other thing, and this is one of the most important things, is that correlation does not imply causation. So there's only one way that we can establish a causal relationship between two variables, and that is a well-designed experiment, something we'll talk about in the next unit. So that experiment is the only way to establish a causal relationship. Or just causation. Correlation only just shows an association, meaning that somehow they're related, but not necessarily one thing is causing the other. Number 6 here, both variables must be quantitative in order to calculate correlation, because we need to be able to graph those things on an x and a y axis. They must be something numerical. And correlation only describes how strong of a linear relationship there is between two variables. If we notice that those dots are curved, we can still calculate that correlation R, but it's not necessarily going to mean as much. And when we have correlation close to -1 or +1, this doesn't guarantee that there is a linear relationship between the two variables. Other things that we need are a scatter plot. We need to calculate R, the correlation, something called R squared, which we'll tackle in the next couple of lessons. we are going to need something called a residual plot, something else we will look at. And we're going to need the statistics from both variables. Correlation is not resistant, meaning here that it can be strongly affected by just a few outlying observations. We're going to take a look at that. I don't believe it's today, but we are going to look at what happens when we remove outliers and add them in and other things like that. And these last two here, if we have a relationship that is positive, that's going to mean our correlation is greater than 0. So we're going to have a positive number basically. And similarly, if our relationship is negative, that's going to mean our correlation R is also negative, that it is also less than 0. So here we have some examples of our linear relationship and correlation in terms of strength and direction. So we can see that here we have the R value for each of those graphs. And we can see how, based on the way that number changes, the scatter plot is also a different picture there. So just so that way you have it, the equation for calculating R, a correlation, you won't really ever need to do this by hand. Thankfully, we have the nice little tech check that's coming up here. So that way you can just do it all in your calculator. So we have the 1 over the number of individuals or people sampled minus 1 times the sum of each individual X value minus the average of the X values divided by the standard deviation of the X values times the same thing for the Y's. And if you notice and look at these two equations right here, these are both z-score formulas. We know that formula, value minus mean divided by standard deviation. We've done that before. So we're going to take a look at what it means to actually calculate correlation and how we're going to do this in the calculator. Again, that's the brilliant part about this class, is that we can just do everything on the calculator and it's going to do all the hard work for us. So we're going to get down the steps here and then I'll walk through them with you guys. So our first step is you want to hit the mode button on your calculator. And what we're going to do is we're going to find an option called Stat Diagnostics and make sure it says on. Without doing these first two steps, you're not going to be able to see R and something called R squared, which we'll need in future lessons. And that's kind of important. After that, we can do exactly the same steps that we would start with for making a scatter plot. So we want to enter our explanatory data in L1 and our response data in L2. You got to make sure that they're all in there. Everything matches, you're not missing a number, you haven't typed in anything wrong. And then what you're going to hit is you're going to press that Stat button. And you want to scroll over to something that says Calc. In Calc, you're going to look for the option that says, Lin Reg, like linear regression. And we want the one that says A plus BX. Now that's kind of important in that it's A plus BX, not the B plus AX. Once you hit that button, that Lin Reg A plus BX, you're just going to hit enter until the number pops up. So let's look at this together and see the steps that we need to take. So here I am on a calculator, and remember, first step, I want to go to mode And I want to make sure that my stat diagnostic is on. So you're going to scroll down until you see this option. Notice that the on is already highlighted. I'm just going to go back up and make sure I hit that again, just to make sure. Now from here, we can enter our data into the list. So remember, to enter data, we hit stat, and then we can just hit enter right away. Now this is data from an old problem. So if you have this situation where you have data already in your list, you can go up until the name is highlighted, hit the clear button, and then scroll back down, and the numbers are gone. Then we can just enter our data. So we have hours spent on social media as our explanatory. So we're going to go ahead and enter that data. So we got 1, 3, 3, 5, 6, 6, 7, 3 8s. So we got our explanatory, and now when we make our response, we just got to make sure we also have 14 values. So we'll go ahead and type those in. There we go. Sometimes it takes a little bit of work. And now we have all of our data. So we've gone through step 3. Now we just need to press stat, go over to calc, and we want ln reg a plus bx. So this 8th option down here, that's what we want. So we're going to hit enter, make sure our X list and our Y list both say L1 and L2 in that order. And you can just scroll all the way down until you get to calculate and hit enter. When you get to that screen, it's going to show an A and a B, which we'll talk about in our next lesson, an R squared, which we'll also talk about, and then our R value, which is what we want. So that negative 0.9, let's go round to 3 decimal places there, or let's even say 4, 0.9175. And we can go ahead and write that down. And that is how we can calculate our correlation R. We don't really have to do it by hand. There's no point to it when we have our calculator to help us out. So knowing that we have this correlation of negative 0.91, that is pretty close to a negative 1. And in particular, the negative sign tells us that there's a negative association. And that negative association is between hours on social media and test score. And the actual number, the 0.919175, is what tells us that the linear relationship is very, very strong. It's very close to that negative 1. It's only, 0.825 away. That's not too much. And the last thing is looking at calculating data from an age of a person that can predict, can age of a person predict how many hours they sleep at night? So this is involving the data from lesson 2.2 and putting that into your calculator. So when we do that, we should get a correlation a correlation value of negative 0.9380. Again, rounded to 4 decimal places. And in fact, it's going to tell us the exact same thing that the one above us did, that the negative tells us that age and hours of sleep have a negative association. And the actual number itself, 0.938, says that the linear relationship is strong. And you can remember, calculate this value by just using those same exact steps. We get to that negative 0.9175 up above. That is our independent lesson on correlation. Thank you all very much, and I will see you for our next class.